Okay, I'll be starting with that odd shaped piece of cast iron, and I want to make some kind of roughly square part for something to start with. So same technique as before. Going to be using a 14 millimeter end mill. .700 RPMs, and I'm getting kind of sprayed a little bit. And naturally I'm not using any oil because I want to be using this thing for to apply glue after that, so I don't want to just soak it up with oil. This is very nice quality cast iron. There's lots of iron in there. Machine's very good for. And I'm using a high-speed steel cutter in here. That's all. Everything's going very fine. How to make a mess. And Philip's not even here. Jeez. Okay, I'm wanting to locate this this key for installation on the square block, so it sits in place and doesn't move. I'm going to be leaving myself a little room here. I want to be able to have some material to chew up a little bit when on the rotary table. So I'm going to be using this adjustable parallel. There we go. I'll have the screw on, and this one here, same principle. I'm going to be using the parallel here, and I'm going to be measuring right after. Okay, now I got the measurements. They're all brought on my I'm not working with CAD because I'm not a specialist at CAD, but I'm a specialist at PAD. It's a paper-aided design. Simple enough. Always make sure that when you make your drawings or take your measurements, you always have a reference corner. Like this corner here will correspond to this corner there, and always make your measurements. Let's say you got 555 thousandths of an inch there, and you got let's say the other measurement is 1 inch 524. You're not going to start 1 inch 524 from here and bring it to there. You always get to your 0 and you make your measurements from the start. This avoids stupid errors sometimes, and just believe me, it's the way to do it. Like same thing on the other axis there. You start 757 there, and when you add the 318, which is the measurement of the height of this thing here, you end up 757, and you always get to the 0 mark there and add it up. Never reference your measurements from this here, because you're going to add up errors eventually, and that's not exactly what you want. So let's get to the height gauge and translate the measurements on this block. Quickly here, I origin this height gauge to 0. If it's vernier type height gauge, no problem. I need 757, which is going to be my first measurement. 757. This is close to, let's say, like half thousand. So there's no height gauge or vernier, whatever, that's going to give you a perfect reading. like a micrometer will. So 757, let's make a first scratch. No need to scratch very hard. Second one will be 1 inch and 75 thousandths. 1 inch and 75 thousandths. There we go. This is my width for the slot. Notice that I started my 0 on this little mark there in the corner, as it's supposed to be on the pad. Paper the design. I'm all proud of that. Okay, next corner. It's going to be this one here. And measurement will be 555 for the first one. 555. Sometimes you have to fool around a little bit, but not always. 555. Second one will be, we add on 2 inches 95 thousandths. 2 inches 95 thousandths. We're getting close. There we go. We got it exactly. And here, I think you should be able to see we're getting the square defined. If the surface finish is not exactly great, it's perfect because it's going to be you know, applied with epoxy later on. And if you got some irregularities in the finish, I mean, it's better. It's going to give some gripping surface. Very simply here, I measured from the corner there, centered the 3/16 and mill there. It's not the required width, but the next step will be using a 1/8 end mill, because as we all know, it's pretty hard to make square corners there, so we'll minimize the radiuses in the corners there. So let's make the slot there to the required depth. The required depth is 145 thousandths. I'm running this at 1200 RPMs. I've already made my 0. Supposed to be a center cutting end mill. We'll find out soon enough. Yeah, so far so good. We're almost there. Let's make it to the required depth right away and start moving. It's going good. Near the end. Yeah, I'll do some regrind. That's it for this one. Let's go with the 1/8 of an inch, 1/8 of an inch end mill. Let's go easy. Full depth. Maybe you see a bozo. Maybe not. Okay, we're getting into the meaty part. I'm not very afraid of blind milling on this. That's it, we're there. What I'm going to do, I'm going to leave the end mill right in that corner. If I have to recenter, I'll use these coordinates. There you go. If that doesn't fit, easy to get the spot. Yeah, I'm going exactly according to the lines, and let's go test this. Okay, the corners are not going to go in, but the width, I got a few, maybe well, I would say 4 or 5 thousandths of slack, which will allow the epoxy to go in, and I think that's going to be fine. Length, that should be, the length is nice also, because I'm kind of avoiding the just at an angle like that, the corners there will fit into the straight parts. But so far so good. I'll probably just, what I do just to clean the give it a little clean up on the corners there, and round off these ones here. That should be pretty easy to do. Okay, it's almost ready to have the adhesive on it. I just reserved myself some space here for eventually adding some pins or screws or hardware to do a better hole. But they're, let's say, tap holes for tap size holes for number 8 screws. But could be spring pins, could be screws, could be whatever. You're gonna say it's horrible finish, and you're right, but it's totally desirable. If you let's say I just kind of really badly scratch the sides here, see, like I'll make it really deep, and cleaned it up with acetone or lacquer thinner or alcohol, whatever. Make sure there's no grease in there. I did the same thing in there for the if you can probably see, yeah, I think you can see inside there too, the grooves, the bad finish, the other side also. And that's when this is going to be sitting on top here, this will, like the adhesive parts, it's going to be a pretty thin coat, but it's going to be, you know, mingling, you know, between the cracks and everything. That's going to improve adhesion. Okay, that's one step coming along pretty good. Time to stick this on the key there. And what am I going to be using for sticking this? The product is called epoxy. It's made by Miller Stephenson, and this is the epoxy, the MS 907 Plus. This was a product that I've been using for a couple of years now. See the box, and my stash was kind of getting vented out, or not as good as it used to be, and I didn't want to take a chance to use a maybe a outdated product on this. So I called the company again just to see where I could get the stuff, and or if they had anything that could be maybe even a better product. But they say the 907 Plus, and oh, that's a good product. That's about one of the good products you can get. These are not exactly available readily out of a counter somewhere. So the nice lady there for the technical support, she offered to send me a sample, so that was free of charge. I say thank you to that person for the assistance, and also for sending me the product. So I offered to mention the company name and the product name on the channel. So Good epoxies. Like I said, I've been using this for 40 years plus, or just about that. So let's prepare a batch and stick this. So that's a and B product, 2 tubes, has to be mixed in even quantity. This is the A product, like a creamy color. I'm not going to be needing much because I always make it so the least you need, the better it is. The other product, the B product, is darker colored. Come on, you. Usually this, there's one that's act as an hardener, the other one act as a resin. I didn't use a scale, but I'm gonna judge by the looks, the proportions. I think that looks pretty much right. And good mixing. Let's try not to introduce too much air, bubbles or whatever. This is not great for the strength. So it's like I'm not preparing very much. I hope I have enough, but I think so. This will take, in the garage here in the shop, it's not very warm, so it will take the full 24 hours for sure to get hard enough and really get, to standard. But epoxies usually will take 7 to 10 days to get like very close to their maximum strength. Let's apply this here. There we go. Thin coat will do, because the fit is pretty good, and this thing should ooze a little bit when looks good. Looks good. Yeah. What I'm checking is making sure that that thing is spreaded pretty evenly. It's got it all over the place. Now we'll squeeze this. I think we're having a good match there. Oh yeah, I like this. I even made too much. There you go. I don't mind about the bumps on there. I don't care. It's just like I need a good fit. That's it. Cheater bar. There you go. I think you see the oozing all over the place. Oozing in there. This means it's filled. Filled there too. Yeah, I'm quite happy with the result. So let this get warm, and let this cure, and we'll be back soon.